We're looking at a piece of software called Stellarium. Okay, so we look up at the sky and face north, and there we go. Everything is rotating anti-clockwise around Polaris. Now, if we face south, then in the planisphere projection, which is very much like what you would actually see, as opposed to some of the other projections that you can commonly see, which don't reflect what you would actually see very closely. But in this projection, when we look south and we're standing in the UK, we see the stuff sort of drifting across the sky. It's not a rotation in field of view we're looking here really here. It's a sort of flow of stars here from left to right. Okay, so what happens in this projection if I visit Australia or New Zealand? So we click down to New Zealand, and in New Zealand I'm now going to face, so at the moment I'm facing south. Okay, so in New Zealand facing south, what do we see? We see the stars rotating clockwise. And I'm facing south. And they're rotating clockwise around the pole there. Okay. So that matches up with what we would expect to see. A clockwise rotation as opposed to an anti-clockwise rotation, which you see in the northern hemisphere. And when I turn around and I look north, what do I see? I see the kind of flow of stars from one side of the sky to the other, going the opposite direction. So what's the point of what I've shown you? Well, it shows you that in the planisphere projection, there's only one axis of rotation going on. So the stars are only circulating around one point, and when you look in the other direction, they are not circulating around a point at all. Okay, so that is what we observe in both hemispheres, except that the direction is reversed. So we see things rotating around when we look north in England, and when we look south in New Zealand. So we're led to believe that that's because in New Zealand, so if you're in New Zealand, you think you're looking towards the South Pole, because South Pole doesn't exist in the flat Earth model. When you're looking south in New Zealand, you're looking to what us in Europe and say England, the UK, is north. So if you look south in New Zealand, you're really looking north from a UK person's perspective. And if you're looking north from a New Zealand perspective, you're looking south from a UK perspective. So if you look at the flat Earth map, you can see why that is, because the north and south are opposing each other. They're 180 degrees apart. So it doesn't enter into anyone's minds to think about this in the globe model, because, of course, in the globe model, they don't think they're looking at the same thing. They think they're on the bottom of the world. So what I've showed you explains how in a flat Earth model you would observe exactly the same phenomena as you see in the spherical world model. So I can go to Australia and see what I'm told I'm going to see, the rotation around what I'm told is a south pole when I look south, and a kind of indistinct kind of flow of stars when I look north. And in the northern hemisphere, I'm seeing what I should. So I see what I should when I'm in what I think is the appropriate hemisphere. But it's all a big hoax.
In an astrolabe, the Earth is represented in stereographic projection on a flat plate called the mater. The ecliptic circle and important stars are represented on another plate called the ret. Different planetary orbits could likewise be represented by different plates, and these would be seen projected onto the Earth plate when one looks down on the instrument. The Bhagavatam similarly presents the orbits of the Sun, the Moon, and important stars on a series of planes parallel to Bhumandala. The orbits of the planets are placed on additional parallel planes. Here we see the Bhagavatam's model of the orbits of the Sun, Moon, and 28 important star constellations. These lie in 3 planes parallel to Bhumandala. The layout is comparable to that of an astrolabe. Seen from above, everything falls into place in projection in an astronomically realistic way.
So now we look up Sigma Octantis in Google Images, right? Because that's the easiest and fastest way to find it. Well, guess what? You cannot find no real photos of Sigma Octantis. You can't. Okay? Look at this, right? This isn't a real photo. This right here isn't even a real photo as a, supposedly, you can tell this is bull. Okay? No real photos, no real photo. And you're going to ask me, how do I know it's bull? Because when you do the research, you're going to find out that they can't even capture it on camera. Okay? And I'm going to get to that in a second. This isn't a real star. These are fake. All of this is computer image. Fake. Where's Sigma? If Sigma Octantis even exists, it doesn't exist, in my opinion. Okay? It doesn't exist. All right? Now, here we go. This is the Brazilian flag. And they put all these stars here, and they stuck this one star. Now, because Brazil's in the southern hemisphere. They stuck this star on the outside of this rim here. Okay? Now, they'll say Sigma Octantis is inside these stars here. But that's nonsense. This is supposed to be Sigma Octantis. They stuck it out because it's not there. That's why. Okay? So we'll move past that. And I know you guys are going to try to debate me on that, but whatever. You guys don't know what you're talking about. All right, so here's a constellation guide. It never sets below the horizon. No stars do, like I said in my other videos. It does not have any star. It does not have any stars brighter than the 4th magnitude. Octanes contain the southern pole star Sigma Octantis, which is located about a degree away from the south celestial pole. The star cannot be used in navigation because it's too faint. Okay, so you can't even see it with the naked eye. You could people claim they see it with a telescope, but you can barely see it. Okay, and this is supposedly the guy Nicholas Louis de Gaulle, who supposedly discovered it, right? And look what he said. He measured the radius of the Earth and came to the conclusion that it's pear-shaped, right? And that was up to much debate, right? So he got in trouble for this, for saying that the Earth was pear-shaped. Okay, which if anybody knows what a pear looks like, that's not even an oblate spheroid. And the reason they say this is because the Earth is flat, right? So you guys will believe this guy who discovered the South Star, but yet you won't believe this, that it's pear-shaped, right? So they debate him on that. So now this is circumpolar, a circumpolar star, supposedly the North Star, but this is how it's supposed to go around. But the problem here is that you can never see it fully go around because the sun would rise by the time this happened. Nobody's ever seen the stars do this. You can't see stars go 360 degrees around. So now, when we look here and we look at these, now look at this nonsense. This is supposedly a time-lapse video of the stars going around. Some of these stars here doing a 180-degree turn down by the closer to the poles. The stars at top have a wider circumference. So they would be doing more than 180 degrees, which means the sun and the moon would have rose up again. This is an impossible photo. Total BS. Okay? But anyway, you know, we're talking about South Star, and a lot of people say, well, the South Star rotates clockwise, the North Star rotates counterclockwise, and vice versa. Well, the deal is, if you're standing in the south, you will see the stars going the opposite. Well, if you're facing the south and you're towards a so-called southern hemisphere, it doesn't really exist, where you're talking about the outer edges of the towards the Antarctica. Let's go there and actually see it, right? So I designed something so we can actually be there, okay? So let's do that, really. All right, so now, if you're standing here where the thumbtack is, right? And you're facing the Antarctica, the stars are gonna move in the opposite direction. That's just common sense, right? The stars are gonna move in the opposite direction if you were facing the North Pole. So if you are facing the center where the North Pole is, the stars are going to be moving the opposite direction. You turn around, they're going to be facing the other way. Okay? You're out in the wilderness, right? Now you got your telescope and you're looking at Sigma Octantis, right? Okay, you're looking at it. You can't see it barely, hardly anything, right? In fact, they say you need a laser. If you have a telescope, you need a laser to actually see it. Okay, to point you in the right direction. It doesn't exist. That's what I'm trying to tell you guys. Depending on where you're facing, going to depend on where the stars are moving. So of course, if you're facing one way, the stars are moving clockwise, and if you're facing the other way, they're moving counterclockwise. Okay, on a flat Earth map, it has nothing to do with the stars rotating around the South Pole, the pole star. It doesn't exist. Okay, and you couldn't see it rotate around the pole star because, like I said before, 360 degrees, the sun would come back up. Okay, so if the stars are moving in on the left hand side, okay, and you're facing the north, as soon as you turn around and you face the south, they're going to be moving in on your right hand side. All right, so again, this whole thing about Sigma, the South Star, the South Pole star, it doesn't exist. All right, so here is Australia, big sky and photographers, patience lead to stunning time-lapse images. So here we're looking at this picture right here is impossible. Even if we did live on a globe and you were taking a time lapse, it wouldn't look like this. Okay, it wouldn't look like this, especially not in the daytime. This is just the way the angles are. If you look at the angles, even if you're in the North Pole, you would have to be looking straight up. Now, if you're looking on an angle, these stars down here wouldn't be in a perfect circle. Everyone who knows about art and drawing knows this is not real. Okay, so we'll take a look at some more of these here. All right, now here's another impossible photo. Supposedly a time-lapse video. This is not real because, again, these stars reflecting off of the ocean like this is not real. These are all composites, fake drawings, and it's always I don't know any other way to explain it. I mean, you could just tell by the angle. There's no way this can be real. And I'm not just saying that because I want it not to be real. I'm saying if you just look at it, use a little bit of common sense, you'll know it's fake. Because the stars will not reflect off of the water like that. I'm sorry. It would be blurred, okay? Oh, man. All right, let's hear it. This is a time-lapse video from the International Space Station. So let's take a look at this. Bullshit. Come on, guys. We gotta be smarter than this. This is bullshit. This is so much bullshit right here. This is video game bullshit. If the Earth is rotating like such, right? And you're, let's say, up here towards, you're at the tip of Canada, right? You're right near the, you're really close to the North Pole, right? If the Earth is spinning and the star trails are moving, rotating because the Earth is spinning, but the Earth is also going around the sun. It's also moving. So the stars will not have a perfect circular motion. They will start to blur a little bit, okay?